Today I will talk about image acquisition system. If you recall, this is the first step in the flow chart for the key stages in digital image processing. I have explained this in the earlier videos, so I highly recommend you watch them first. And don't forget to hit like and subscribe. And if you have any questions or suggestions, leave them in the comment section below. Now, imaging system consists of two parts, the hardware and the software. The hardware includes the image acquisition system, image acquisition system, that is how we acquire the image, the computer, and the display. The software includes manipulating the image, analyzing and processing the image. Now, let us look at the typical imaging system. Let me zoom in for a better view. This can be called as a typical image system. Here are the image acquisition hardware, which can include a camera or a scanner or a video player. This is the computer system. These are the image display hardware, which can include the monitor, printer, a file format, or a video recorder. Let me zoom out and move on to the next thing. To acquire images, we need sensors. We will be looking at a few different sensors in this video. Okay, let me zoom in for a better view. Image sensor. It can be of a single sensor. It has sensing materials, it has power in, the energy falls here, and this is the voltage waveform that we need. When a single sensor is placed side by side in a horizontal or vertical format, it is called as line sensor. If it is arranged in a two-dimensional format, it is called as an array sensor. This is a different sort of sensor. This is combining a single sensor with a motion to generate a 2D image. This is the sensor. The sensor moves from this end to this end. This is the film and it rotates. In this way, we get a 2D rotation. Other forms of sensor. These are some other forms of sensor. This is a finger sweep sensor. You sweep it across here. This is the sensor strip where it senses the image. This is a computerized axial tomography sensor. This is a charge coupled device, which is a different sort of sensor. It is used to convert a continuous image into a digital image. It contains an array of light sensors. It works with photons. It converts photons into electric charges accumulated in each sensor unit. This is a typical format of how we can acquire an image using a sensor array. Here we have the illumination or the light source. The light source falls on this object, the object which we want to create an image of, and this goes to our imaging system. The light falls here and is reflected back into our imaging system. Now let's see how this works. The imaging system, it reflects the object on an internal imaging plane. As we can see, this is the object, this is the imaging system. The imaging system puts it on an internal image plane. The internal image plane then digitizes the output into this format. As we have previously seen in our introduction videos, that this is the digital representation of this object. Now we will look at an image formation model. Suppose this is an image. This is the x-axis. X increments this way, which means this is 0, this is suppose 1, 2 and so on, and y increases this way. This is 0, this is 1, this is 2 and so on. An image is a multidimensional function of spatial coordinates. It is a multidimensional function, which is why we have the fxy, which is the function. Okay, so what is a spatial coordinate? Spatial coordinate, it can be xy for 2D images, it can be xyz for 3D images such as CT scan, it can be xyt for movies. T here represents the time. Now, the values of fxy can be from 0, as we start from here, to alpha. Alpha is the last value. I will stop here today. In the next video, we will be looking at two very important terms, sampling and quantization. Thank you for listening.